I'm from New Zealand. I moved here when I was 17 to go to MIT.
Okay.
And after that, started a I started a biotech software company in North Carolina. And we did that for about 3 years, and then it got acquired by a company in Boston, where I moved back to Boston and worked there for about 4 more years.
Wow.
Then, while I was there, I wrote this book, and then decided to move to San Francisco because I'd always wanted to live there.
What sort of biotech firm what sort of technology did you develop, or what was the focus of it?
The focus of it was to build network simulations so that pharmaceutical companies could come in and they would have a series of observations, and we would say, here's what we think's happening based on the structure of protein interactions and stuff like that. So we think maybe that this is the root cause up here that's causing all these observations that you're seeing.
Wow. Did you study some biology to be able to do that, or?
I picked it up along the way. We had to obviously take a lot of science classes at MIT in addition to my computer science stuff, so I'd learned microbiology there, and then sort of got into it.
Okay. Okay, great. But your major was mathematics, computer science?
Computer science.
Okay,
yeah.
Fantastic. Great. And so now, where are you working?
I work at a company called MetaWeb, and our product is Freebase.com,
Okay.
and it's a massive semantic open database. Anyone can contribute, and I work on the data team, so we're trying to put as much interesting data in there as possible by extracting meaning from Wikipedia, natural language processing, stuff like that, but also from publicly available databases like the Securities Exchange Commission and the FDA and the FCC and all these sort of sources that are out there. We're trying to link them all together so that people can do really sophisticated queries.
Wow, that's really fascinating. So let's just talk briefly a little bit about your last book, Collective Intelligence. So for those that don't know, what is collective intelligence?
Collective intelligence is the idea that I think we actually had a CI foo camp where we came up with a good definition, which is that the network knows what the nodes don't.
Okay.
Just that once you get people working together, you can use individual contributions and combine them in a way that produces entirely new outcomes. So a good example of this, one of the most common examples of this is Amazon's recommendation system. Because a lot of people go and buy things, they don't realize they're contributing to a greater intelligence, but it allows Amazon to build this sort of product matrix which lets them learn when people who like this also like this. And this is sort of an example where no one's gone through and curated this information.
So, yeah.
Amazon just sort of learns by watching what people do.
Yeah. Is this why they ask me what my zip code is when I go to the grocery store?
Yeah.
Is that right?
They want to collect statistics. Eventually, I think Safeway is one of the biggest data sets of consumer data, because...
Wow. Now, you chose to write this book in Python.
Yeah.
Is that the language you normally use?
It's the language I use now.
Okay.
At the time I wrote the book, I was mostly using Java,
Okay.
but I preferred Python as a programming language because
is that right?
I found it much easier to express thoughts more directly.
Do you think it's better suited for the sort of intelligence work that you're kind of doing, or like that knowledge information?
It's
knowledge
better suited
engineering?
for experimentation,
Okay.
for sure. And when you're designing a machine learning algorithm, a lot of it is just trying different things and trying to figure out what works. And Python's so flexible that it allows that. Also, the aspects of it that are functional programming, like that I could write one class and pass in different functions to do word splitting or something like that.
So you really rely on the functional paradigms in Python
Yeah.
to extract its power.
Yeah.
So, and Java just doesn't have that.
Java doesn't have that at all, actually. Python's a multi-paradigm language, so you can sort of take the best approach the approach that works best.
You have a section in your book on machine learning and collective intelligence. You talk a little about machine learning.
Most of the book is using machine learning algorithms to understand social data, like what people are doing take what a lot of people are doing on the internet, use machine learning and data mining techniques to come up with new conclusions.
So what are some of the techniques you talk about for doing this? You had a number of sections on.
So I have a section on decision trees. I have some other techniques in there, hierarchical clustering, k-means clustering, support vector machines. What else?
So a lot of those are statistical concepts too.
Yeah.
And you're able to describe how you would use that statistical concept in Python. So there's lots of packages for this sort of.
Yeah, some of them I try to use packages where possible a lot of times, but I also want to take people through the code so they know exactly how it's working. I think it's important if you're going to use a library that you understand what the different options mean, and sometimes the best way to do that is to implement a simple version of the algorithm yourself.
Yeah.
See how it works.
Wow.
And also, a lot of people have told me because I have the code, they can go translate it to Ruby or Scala or whichever language.
Or just copy and paste it.
Yeah.
And use it on your projects.
Well, because a lot of these sort of newer languages don't necessarily have a machine learning library, and so it's great for them that there's instructions on how you write it in Python, and
I see.
simple enough that they can translate it to Ruby or.
You also discussed evolving intelligence. Can you explain what that concept means? And
So there's a concept called genetic programming, which is that you sort of use the ideas of natural selection to create new programs. And that what you do is you represent a program as a tree, and you basically have them battle.
Wow.
And the ones that win, get to continue on, and and there's different ways, like you have them breed with each other, which means nodes from different parts of the tree get swapped out, and also they mutate. And over time, you can sort of have the program write itself. All you need is a way to judge how well it's doing. And it's very computationally intensive, so people can only really use it for simple problems right now, but I think it'll become more important in the future.
What sort of problems would genetic programming be useful for, like real-world problems?
So the example I always hear is that NASA used genetic programming to design antennas, because they could simulate certain aspects of the radio spectrum and understand how well an antenna would work. And they actually just had this evolving antenna design that in the end turned out much better than the best one that the human designer had created.
Oh, wow, very interesting. Why do you care about free data? And maybe?
So I've been thinking about this a lot, and what you start to notice after a while is that people keep recreating the same data sets again and again. If I want to build my own version of a restaurant review site, I've got to go collect all the restaurants in each city, or expect people to contribute them, and then everyone who does that sticks a copyright on it so no one else can use it. And then there are also examples where companies are selling processed versions of government databases, like there's companies like Capital IQ which resell the SEC data, and that's what Yahoo Finance uses. But you're not really supposed to go and download that for yourself. And so what we have in the world is all this duplicated effort of recreating the same database over and over again, even though it's sort of peripheral to the interests of the company. The purpose of Yelp is to be a review site. It's not to be a directory of restaurants, and so Google Local has to have the same thing. They all have to have the same database, and it also means that if I just had an idea for a cool little thing that wasn't going to be a big business, I can't even get started because I don't have the data to back up my movie review site or my restaurant review site or whatever it is, or my stock screening program. And so what we're trying to do at Freebase, and what a lot of people are trying to do actually, there's some great efforts out there to liberate data.
So like an open source movement in data.
Yeah, exactly. Aaron Schwartz and Carl Malmud and all those guys, they're trying to liberate data, sort of make it open, because once it's out there, you never know what people are going to do with it, and it could be amazing, right? Like one of the classic examples that's held up of free data being used in a way that was unexpected is the Chicago crime maps that Adrian Holivardi did, where he took the crime reports and he like mashed up with a Google map, and it was one of the first map mashups, and people were like, wow, we can really see where crime is happening in a way that we just couldn't before. And now, of course, there's map mashups of everything, but that was sort of a very original new idea that he was able to do because the data of crime information was free. And you just never know what people are going to do. And
sure, there's all sorts of possibilities. And if someone, probably also interesting is if there's the interesting intersection of data.
Right.
So you might have GIS information on one hand, like geographical data, and then say genetic information on the other. And if you could somehow overlap that, you could do really interesting things with
genealogy or and
exactly.
the Census Bureau. You have so much data out there. And a lot of it is free already, but people don't know how to use it right, and so we sort of have these middlemen who process it for you. And
it seems like languages like Ruby and Python really give you the opportunity to sort of utilize that information with a lot of the packages that they...
I mean, there's a lot of sort of the parsing stuff is taken care of to some extent, but then there's all the ways to combine it. Like, how do you know if these two databases are talking about the same thing and stuff like that?
That was something that impressed me when I read your book, is just how you were able to overlap just the pure pragmatics of like using Python and all these really powerful mashups you were able to do with the libraries that were available using Python, and then also in really interesting and novel examples. And you have so it's really like your book seems like it's an AI book, part statistics, and also a Python programming book. It has all those elements.
Yeah, that's really what I was trying to go for. When I was working in biotech, I sort of felt like there weren't enough people who understood algorithms and AI specifically, because they didn't feel like it was very useful. Like, it's something you learn in school, but then once you get a job, you're building web pages and sticking a database behind it, and you are learning more complicated things, but it tends to be more around like, how do I scale this, or something like that. And people didn't really understand why they would use machine learning in a regular job that was for academic researchers. And what I wanted to do was create a book where people could see that this was useful for like the sort of consumer web apps they were building, and that it was completely accessible to them. That, you know, if you look at the code, it's not that complicated. It's something that anyone can do. And I didn't, go deep into the algorithms, into AI, because it was really to introduce the concepts. And I also sort of feel like you get more value out of finding different ways to get data, like looking at different open APIs and stuff like that, than you do out of trying to go too hardcore on the data that you have, right? Like making the algorithm more and more sophisticated. You're often better off just trying to find new sources of information that give you more input.
Interesting. So you're now working on a new book on the semantic web. So tell me a little bit about, like, what is the semantic web?
So the semantic web people have been talking about for a very long time. And I think a lot of people have been disappointed that there hasn't been much progress. So, but there's actually a lot of cool research that's happened, and there's some stuff that you can do right now. It's not the big vision that Tim Berners-Lee has constantly laid down of my agent negotiating with my doctor or whatever it is. It's much, but there are ways to combine, new ways to combine data, and this is feeds into the free data story, which is that we want people to be able to publish things in a way that's usable. And so I'm writing the book with two other authors, Jamie Taylor and Colin Evans, who also they have a lot of experience in the semantic web. And our plan is to basically do for semantic web stuff what we hope this book did for
AI.
machine learning,
Yeah.
which is show people that they can do cool stuff with it right now. Go through practical examples.
So what are some of the things that you talk about? What are some of the things that we can do right now using semantic web technologies?
So one thing is that if you put the upfront investment into representing your data as a graph in triples instead of instead of a rigid database design, it becomes so much easier to add in new data sources as you go.
Oh, really?
And this is sort of like the perpetual beta Web 2.0 thing, which is that software's never done, right?
Yeah.
There's always going to be a new data source coming along that you'd be like, oh, that would be really cool. And so I actually demonstrated this at the Semantic Web conference. I had my database was a JavaScript triple store running in the browser, and it mashed it all up within the browser using this triple store. It built a little graph by going out, fetching data, and incorporating it, so we could show that you could add any new data source to a map with just a couple of lines of JavaScript, and then add temporal information about when events were happening and things like that.
Do technologies like OWL and RDF support that implementation?
Yeah, I mean, RDF is a method of representing a graph. It's basically a file format, right?
Okay.
And so it's good to have these open standards of how you would represent something. OWL is a way of describing a domain. It's an ontology language.
Okay.
So it's obviously much easier to integrate data if we all agree how we're going to talk about it.
Sure. I think the whole concept of an ontology and a controlled vocabulary are very powerful concepts that aren't really commonplace in most technical parlance. You just don't hear much about it.
Right.
But it is very much connected with the semantic web vision. I don't think it just should be exclusively defined for semantic web talk, but it's out there.
Yeah.
Can you sort of just talk briefly about what an ontology is and how it's so integral to sort of the next step? And
well, an ontology is it's basically an agreement that when we say this is what it means, right? And I think people can take it a little bit far. They're like, oh, we can define an ontology for everything, which is like sort of what the Psych project was doing, and it gets far too complicated. But for specific domains, it can make a lot of sense. Like if we're all going to agree that within this company, there's a lot of in the Defense Department and stuff like that. That when we say that we're buying this part, here's how we say that, and as long as we agree on the ontology up front, like all the data will interoperate.
yeah.
And one of the reasons that I think the semantic web has struggled a little bit is because people have tried to make it too broad, like we can make an ontology for everything that everyone will use.
Wow.
And it's hard to get people to agree to that. So, I mean, that's the basic idea without getting too technical.
Oh, that's great. Well, so your approach is you look to the fringe of things that are enticing and powerful, but not yet mainstream, and you're bringing it into the mainstream community. That's very entrepreneurial.
I mean, I didn't really think about it as my thing, but I guess that's how it's turning out.
Okay, well, thank you very much for your time, and thank you.
Thanks.